Good morning. It's the 24th of the 9th, 2021, and today we're going to look at the second of Berriman's digits, and this one is 0.7291666 recurring imperial inches. And Berriman gives this as 35 over 27 multiplied by 9 over 16, which is 315 over 432. And we can translate this at Giza because there are 20 digits in a Riemann, and Riemann root 2 is the royal cubit, and we can produce a royal cubit. And it's this digit, the digit 2, multiplied by 20 to give the Riemann, and then by root 2 as 99 over 70. To give 20.625 as the royal cubit. Multiply that by 1760 to get the Giza base, and then divide it by 44 multiplied by 7 to get the height in imperial units, and the height is 5775 imperial units using this imperial digit here. And we know 5775 is 100 zapal. We've already been through that on a previous presentation. So we can convert to decimal, to centimetres, by using 100 divided by 39.375. And we find the digit in centimetres is 1.851851 recurring centimetres. And this, when we multiply it out, is giving a Giza height as 14666.666 centimetres, which is the equivalent of 5775 imperial inches, as we've seen with the zapal. And that is obviously a very significant number for the height of the Giza pyramid, because it's based on the eclipse unit. Now we can convert this into what we can call a finger, because the metric finger is shorter than smaller, not as long as the metric digit. So the way we do that is we use Professor Greaves' fraction of the imperial foot to produce the Roman foot. So we multiply it by 0.972. So we multiply the digit by 0.972 to get the finger. And the finger then becomes 1.8 centimetres. And now we've got some nice round numbers. We find the Riemann becomes 36 centimetres in this case. And the Giza height falls to 14256. And now we're going to go above that by converting this, by dividing it by 1.8 and multiplying it by 2 to get this row, which is the 2 centimetre row. We find the height now it's gone up to 15840, and when we have a 4 centimetre digit, the height becomes 31680 centimetres. Finally, 5 centimetres produces 39600, and that's the base 100 metre in inches, but in this case it's centimetres. But there's the base 100, the Riemann becomes 100. And the royal cubit in this instance is 100 times root 2. It's there. So we can see this is a completely different interpretation of the design of the Giza pyramid using centimetres. Now we can extend this to this line here by putting this row of figures in. So we can do it fractionally, which is what we need to do. So we multiply the digit by 20 then we multiply it by root 2, to get the royal cubit, which we then multiply by 1760, and we get the Giza base in imperial inches, so we can multiply that out. Quite a large number. And then we drag that down, and we can get the full analysis in as fractions. So we've got 109,7712,000 divided by 3024,0 to give 363. And what we can see from this analysis is that to get a base of 36666.666 recurring inches, we have to multiply this by 100 over 99. Doesn't fit. It won't take it. It doesn't matter. It works out as 36666.667, even though that is too big for the cell. So there we go. Now what we can find here is that another way to do this is multiply 1760 by 100 over 99. And 1760 multiplied by 100 over 99 is 1777.778, and we can see what the Egyptians were doing here with this design, because that is 16 over 9 times 1,000. So they're cancelling out this fraction here. They're cancelling out that fraction to produce this figure. So when we use 1760, we get this 363, but when we multiply it by 100 over 99, we're actually using 1777.77 recurring cubits. And we've already seen this analysis on a previous presentation. I've explained it, but we can see what's working with this digit. That's 9 over 16, and this is 16 over 9. So it's cancelling out. So that's how it's working. But the interesting thing here for me is what's happening in centimetres, because all these figures, this unit here 31680 is 6 miles. So if we divide that by, we get 6. That's the distance between Old Sarum and Stonehenge, exactly, from centre to centre, 6 miles. And John Michel and John Neal are saying that that is one of the founding stones of historical metrology, that number. And if we multiply it by 34, divide it by 33, we get Tom's megalithic yard. But this is all in centimetres, it's not in metres. It's the same system, but all the numbers appear in different places. And John Neal suggested that Berriman had fudged his figures and that he'd forced his royal cubit to be in imperial inches so that it would work with the imperial system. 20.65 is an imperial unit, and it is. And John Neal accuses Berriman of doing this deliberately. But we can see from the fact that he's worked out this 39.375 metre, but not known what was happening on the other side of the coin, on the metric side. He didn't understand this at all. There's absolutely no way that he could have made this up or cheated, because it's there and we found it. So I think Neal has done Berriman a really bad disservice. And I think really some of the things that he said about Berriman are well, they're beyond the pale really, but it's in his book, and I'm not knocking his book because it's a brilliant book, but I think he was too quick to decide that Berriman's work was incorrect, and his substitution of the numbers in place of Berriman's was the right way forward. And I can see why he thought that, but certainly he's missed so much by doing that, and it's been so difficult to unravel his book as a result of his approach and the way that he's negated the impact of Berriman. So that's it for now. Thanks for listening.